Hello all, once again welcome to the LJ Institute of Engineering and Technology. Let's start with the subject Mathematics 2 and our chapter is first order ordinary differential equation. Now, now today's topic is exact differential equation. This is quite different than previous four methods. So let's start with the exact differential equation. A differential equation m dx plus n dy is equal to 0 is said to be exact. Here m and n are function of x and y. This equation is said to be exact if there exists a function u of x comma y, that means a function of x and y, such that total differential of u is equal to m dx plus n dy. Now, what is total differential of u? That means del u by del x into dx plus del u by del y into dy is equal to this m dx plus n dy. Okay, so if this happened, then we can say that this equation is exact differential equation. Now, what is the necessary and sufficient condition to be given differential equation exact? So this is the necessary and sufficient condition that given differential equation to be exact. That means differentiation of this function of x and y m with respect to y partially and differentiation of n of xy with respect to x partially. That means you have to remember like this: the coefficient of dx function, okay, differentiate partially with respect to y, and coefficient of dy function this differentiate partially with respect to x with opposite. Okay, so if this equal, then we can say that that given differential equation is exact. This is necessary and sufficient condition. If it is asked in examination, you can write. Okay, now where this del m by del y and del n by del x are partial derivatives of m and n with respect to y and x respectively. Okay, now what is the solution? Just here we have decided that given differential equation is exact or not by using that necessary sufficient condition. But if it is exact, then how we can find the solution? So the solution of exact differential equation m of xy dx plus n of xy x comma y dy is equal to 0 is given by this. Simply integrate this both side and we can put the integral constant c. Okay, so just we have to integrate this, but to integrate this we have to keep two things in your mind, that whenever we are integrating with respect to x, treat y as a constant and differentiate with respect, integrate with respect to x. And here, whenever we are integrating with respect to y, we have to just take the terms free from x. And we have to ignore the terms which include x. Okay, so here when we integrate with respect to x, just treat y as a constant, okay, and integrate with respect to x. And here when we integrate with respect to y, at that time we have to just consider the terms which are free from x. Now to understand this better, let's have a look on the example. So by using example you can understand better. Now we have this example: solve 5x raised to 4 plus 6x square y square minus 8xy cube dx plus 4x cube y minus 12x square y square minus 5y raised to 4 dx is equal to 0. So this is exactly look like m dx plus n dy. So we will consider this coefficient of dx as m and coefficient of dy as n. Okay, function of x and y. So we have m. Now we know that if we take this term as a m, so we have to differentiate this m partially with respect to y. Coefficient of dx differentiate partially with respect to x, with respect to y. So del m by del y, when we differentiate with respect to y, we know partial derivative already studied in semester 1. So treat x as a constant. So this is our constant sum and differentiation of constant is 0. Okay. Now here we are differentiating with respect to y partially. So 6x square constant and differentiation of y square is 2y. So total 12x square y. And here again differentiating with respect to y, so minus 8x as it is, and differentiation of y cube is 3y square, so multiply with 8x, we have 24xy square. Now coefficient of dy, we will consider this as our n, and we differentiate partially with respect to x. Okay, so we differentiate partially with respect to x, so this 4 and y treated as a constant, so differentiation of x cube is 3x square, so multiply with 4, so 12x square y. Similar way, differentiation of this with respect to x, so 12 and y square constant, and differentiation of x square is 2x, so multiply with 12, so minus 24x y raised to 2. And here in this term we don't have x, so differentiation of constant is 0. So now here we have two value, del m by del y and del n by del x. Just we have to compare the answer of these two. So we can see that both are same. That means del m by del y is equal to del n by del x. That means given differential equation is exact. So here we just find out, or we just decide that given differential equation is exact or not, and we find that given differential equation is exact. If given differential equation is exact, then we have to find the solution, and to find the solution, as we have discussed, we have to just integrate these two with respect to x and with respect to y. But we have to decide that whenever we are differentiating with respect to x, treat y as a constant, and when we differentiate we integrate with respect to y, term free from x, that means we have to omit this term and this term, because this both term contain x, and we have to take only terms free from x. Okay, so the solution is this, and here I just put the value of m entire value, because here we should not remove any term, just we have to treat y as a constant, and here we have to remove the terms which contain x. So we already removed two terms, and we are just taking only term which contain y. So whenever we are integrated with respect to y, only term with y, and with respect to x, we will take entire m, but we will treat y as a constant. Okay, so integration of this, x is to 5 by 5, integration of this, x is to 3 by 3, integration of this, x square by 2, and here integration of this, y is to 5 by 5. This is our final answer by simplifying some terms. So we will get the final answer is this, and this is our general solution. So easy. So you have to just find out m, n, differentiate m with respect to y partially, differentiate n with respect to x partially, and just check if both are equal or not. If equal, then exact; not equal, then not exact; not exact, then we have further lecture for non-exact differential equation. Okay, so we have one more example. We'll take one more example. 1 second. So we have one more example. Solve y e raised to x dx plus 2y plus e raised to x dy is equal to 0. So here this is our m and this is n. So we will start with here m is equal to y e raised to x and n is equal to 2y plus e raised to x. So we'll differentiate this m with respect to y partially. So this e raised to x is constant and differentiation of y is 1, and we differentiate n with respect to x. So this 2y is constant, so 0, and in differentiation of e raised to x is e raised to x. So here we can see that del m by del y is equal to del n by del x. Therefore, given differential equation is exact. Now, if it is exact, then we know that how to find the solution. So the solution is just we have to integrate this m dx plus integrate n dy is equal to c. Now, whenever we are integrate this, at that time I told we will take m entire m, but we will treat y as a constant. But whenever we are taking n, we'll take term free from x. So this is our n, and we'll take term free from x. That means we will not take this, we'll take only 2y. So we have 2y dy is equal to c. Now just simple integration, y constant, integration of e raised to x, e raised to x, and plus 2 integration of y is y square by 2, 2 cancel out, and is equal to c. So final answer is y e raised to x plus y square is equal to c, which is our which is our general solution. So this is the method to solve the exact differential equation. Okay, so similar, we have this entire another example, and this example is different from previous example, that find the exact differential equation du is equal to 0 if u is given. Here u given, you have to find the exact differential equation, that means you have to obtain. Okay, and u is given, and that u is constant which is given. So we know that if u is this x square plus 4y square, so du which is given by this total differential is given by del u by del x dx plus del u by del y dy. Just we have to find these two differentiation of u partially with respect to x and y. We'll put here with respect to x and with respect to y, and here it is given that u is constant. So if u is constant, then its derivative is 0. So we'll take this is equal to 0. So we have 2x dx plus 8y dy is equal to 0, and which is our required exact differential equation. You can check by taking this m and n. This will become compulsory exact differential equation. Okay, so whenever it is asked that form the exact differential equation from given, at that time you have to follow this method. Okay, so these are the DIYs that you have to solve. Okay, that find exact differential equation. Just we solved du is equal to 0 if u is constant and u are this given. So we have 5 example to obtain exact differential equation, and these are the 5 example which in which you have to just first check that given differential equation is exact or not. If it is exact, then find the solution. If it is not exact, then left. Just write down that given differential equation is not exact. Just left. Right now for this method, whenever we have another method, that non-exact differential equation, and method to solve that non-exact differential equation, at that time whenever it is asked in examination, then you have to solve by that method. But right now in this exercise, if you find the given differential equation exact, then you have to solve, and if it is not exact, then just left with the sentence given differential equation is not exact. So before going with the second lecture video, you have to solve this example, each and every example, so you will understand better in next non-exact differential equation, because this lecture will help you to understand better in next lecture. Okay, so thank you very much for today's lecture, and keep practicing. This will help you in examination. So thank you very much.